Good evening, students. Now we are going to discuss about the vector calculus, next part of the vector calculus, that is divergence of a vector point function. So let us look what is the divergence of a vector point function. The divergence of a differentiable vector point function, vector v, is denoted by divergence of vector v. This is denoted by this, and it is defined as divergence of vector v, as you know, this is del dot vector v. And what is the meaning of del? You know, this is this dot vector v. It means this may be written as I dot del v over del x plus j dot del v over del y plus k dot del v over del z. Obviously, the divergence of a vector point function is a scalar point function. So if vector v is equal to v1 iota plus v2 j plus v3 k, then divergence of vector v is equal to del dot vector v. And this may be defined like this dot this. It means del v1 by del x plus del v2 by del y plus del v3 by del z. Since iota dot iota is equal to j dot j is equal to k dot k is equal to 1, as we know, and their dot product if iota dot j, j dot k and k dot iota is equal to 0. Now, what is the next definition is important definition, that is curl of a vector point function. The curl means rotation. Okay, so the curl or rotation of a differentiable vector point function v is denoted by curl v, and it is defined as curl v is equal to del cross vector v. Del cross vector v means this cross vector v. It means iota cross del v by del x plus j cross del v by del y plus k cross del v by del z. Obviously, the curl of a vector point function is a vector point function. You must remember this. This is a vector point function. If vector v is equal to v1 iota plus v2j plus v3k, then curl v is equal to del cross v, and this may be defined like this. Okay? Now, another way to define is, and the simpler way is in the form of determinant iota j k del over del x del over del y del over del z is v1, v2, and v3. So you must remember this form because this is easy also. Iota del over del y v3 minus del over del z v2. You know this. You may take this multiplied by this minus this. Okay. Then again the j, then multiplied by this and minus del over del x by v3 plus k del over del x v2 minus del over del y v1. A field vector v is irrotational. This is very important property. If curl of v is equal to null vector, then that is called field is called irrotational. Okay. Now look one problem. Find the divergence and curl of the vector v is equal to x y z iota plus 3x square yj plus xz square minus y square zk at the point 2 minus 1 1. So first of all, you will find out divergence of v. This may be find like this, and on simplification you will get this minus 1 plus 12 plus 4 minus 1 is 14 at 2 minus 1 1, and then curl v is this. And in this way, you will find twice iota minus 3j minus 14k at 2 minus 1 and 1. Now, this is repeated operator by del. How you look? Let phi xyz be a scalar point function. Then divergence of gradient phi means del of phi means del square phi. Where del square is del 2 phi over del x square plus del 2 phi over del y square and plus del 2 pi over del z square. So divergence of gradient phi is this. That is, if you operate, then you will get this is equal to del square phi. This is one of the important result. Now, curl of gradient phi is equal to del cross del phi is equal to null vector. How you can prove? You can prove like this. Curl of gradient phi means del cross del phi is equal to phi del cross this, and this you may write like this, and finally you will get this is the unit vector. Null vector. Now, divergence of curl v is equal to del cross v is equal to 0, and this proof also you can start by taking vector v as this, and the curl vector v is equal to del cross vector v, and then in this way in the form of determinant you can write, and in this way you can find out, you can establish del dot del cross v. Further, if you are just look the further derivation, then del over del x, you elaborate this, del over del y v3 minus del over del z v2 plus del over del y del v1 by del z minus del v3 by del x plus del of del z of del v2 by del x minus del v1 by del y. And finally, you will get 0. So these are the two important results and two important properties, and you must remember. Then another important part in vector calculus is directional derivative. So let us define what is the directional derivative. Let PQ is equal to del R, then limit del R tends to 0, del phi over del R may be written as del phi over del R, that is n dash dot del phi is called directional derivative of phi at P in the direction of PQ. So here n dash cap n dash is the unit vector in the direction of PQ. And what is the value? Value is del phi over del R is equal to cap n dash dot del of phi. You must remember this. And this is equal to del modulus of del phi into cosine theta, and which is less than or equal to modulus of del phi. Del phi gives the maximum rate of change of phi, and the magnitude of this maximum is modulus of a determinant of del phi. Then look one problem. You find the directional derivative of the function. This at the point P1, 2, 3 in the direction of the line PQ, where Q is the point 504. In what direction it will be maximum? Find also the magnitude of this maximum. So del phi is equal del f is equal to I del f by del x plus j del f by del y plus k del f by del z is equal to 2xi minus 2ij plus 4zk, and this value is this at 1, 2, 3. Now also PQ is equal to OQ minus OP, and that is 4 iota minus 2j plus k. And if vector at this cap n is the unit vector, then the direction PQ, in the direction PQ, then cap n you may calculate as a 4 iota minus 2j plus k divided by under root 21. Directional derivative of f in the direction of vector PQ is equal to del f dot vector n cap n, and this value you will get 4 by 3 under root 21. The directional derivative of the function f is maximum in the direction of the normal to the given surface, that is in the direction of del f is equal to twice iota minus 4j plus 12. Now the maximum value of the directional derivative is mod of our determinant of del f, and this is equal to 2 into under 41. Now these are the problems I want the students to do the practice related on this topic. You find the angle of the surface x square plus y square plus z square at z is equal to x square plus y square minus 3 at the point 2 minus 1 2. Find the gradient phi where phi is this, so that curl of v is equal to gradient of divergence vector v minus del square v. If r is equal to xi plus yj plus zk, then so that divergence of vector r is 3 and curl of vector r is 0. Thank you very much. Thank you.